All right, guys, let's get started, please. Our objective for today, I can apply rational equations. Read together, 1, 2, 3. I can apply rational equations. Question. No further model. And we don't need steps. We already have all the notes for this lesson since we did that before we went to spring break, remember? Yeah. I'll let you know that by tomorrow. Because today I'm going to meet at the high school. So, all right, here we go. So, write your objective. Our lesson, we're still on applying rational equations. So just to recap, here it goes. We did a Fermat model last time. We know what rational equations are. They're equations that contain at least one rational expression. Here they are. This is what they didn't look like. And we said they have to be equations containing at least one rational expression. Okay? And I gave you guys steps. Read the word problem and write rational equation. Then write the rational equation as a proportion, cross multiply. If not, then the equation, make sure you find the LCD, multiply and solve. So, from there, we ended up doing these kind of problems. They were work problems. Remember that? Okay, and then we did another one. Okay, all right. So, copy this one down so like that we can get a little bit of practice on these again. Example 3, copy that. It says, Ileana can make a pizza in 30 minutes. It takes Alyssa 40 minutes to make the same pizza. How long will it take them to make the pizza if they work together? Go. Okay. So, I showed you 2 ways of solving this, right? So we can solve it by 1 over 30p plus 1 over 40p equals to 1 whole pizza. Bless you. This becomes 1 over 70p equals 1. Is that correct? Yes. Oh, common denominator. That's true. Totally forgot. So therefore, we multiply times 40 times 40. So this is 40. Yes. And no. Oh, 120, my man. 120.
Isn't it 1200? Yeah, 1000.
Oh, that's true. This one times 30 times 30. All right, we add these. Yeah. Yeah. How about what if I do this? I confuse you? Okay, so what is our check this out. What is our LCM?
120.
120. Okay, so let me do that. I'm going to go ahead and multiply the entire equation times 120 to get rid of the fractions. Bless you. Boom. Yes. Remember that? So this fits in there, 4p plus 3p equals 120. 7p equals 120. Divide by 7, divide by 7. P equals, let's see, what is it? 17 and 1/7 minutes. So that's one way. What was the other way? Let's see. A times B over A plus B. Was that? That's true. Who did it this first way?
I did.
Who did it the second way?
I was so confused on the second way. I just did the homework.
30 times 40 over 30 plus 40. This becomes 1200. This is 70. Get rid of some zeros. And at the end, we end up with 17 and 1/7 minutes. It's 17.142.8. No. All right. So we got these, right? Any questions with those?
No, Mr. Q.
All right. Where I want to get to is this next one. Copy this one. We're going to start with mixture problems. We're doing two types of mixture problems. What? Oh, really? All right. Copy this one. Example 4, it says, Omar has 20 ounces of a snack mix that is half peanut, half raisin. How many ounces of peanuts should he add to make a mix that has 70% peanuts? Copy that, please. So, once again, it says, Omar has 20 ounces of a snack mix that is half peanuts and half raisins. How many ounces of peanuts should he add to make a mix that is 70% peanuts? So, for this one, check this out. We're going to use, remember the guess and check table to get organized? How many different items are they talking about? 2. So we write 2 lines down, 1, 2. I'm just going to do 2 across. You're just paying attention. However, for this one, I'm not going to write raisins and peanuts. Which are they focusing on here on the question? No, which item? Peanuts. So now check this out. So here on top, I'm going to write peanuts. Total. Okay? Here, I'm going to write the original. And then from here, I'm going to write the new mix. Copy that, please. Goes. So I'm going to set this up. Here it goes. On my original mix, what is the total ounces? Oh, by the way, this I'm going to label ounces. Ounces. What is the total ounces of the original mix? What is it?
20 ounces.
20. So therefore, in the original mix, if the total ounce is 20, and it says half of it is peanuts, so how many ounces are here? 10. So they goes here. Are we there so far? Okay. Now that we have our original, now we go to our new. Here, Omar wants to add peanuts to the new mix. Is that correct? So if on the original he already has 10 ounces, we're going to add more peanuts to that. Is that correct?
Yes.
So the total is going to be 20 ounces plus some more peanuts. Does that pretty much make sense? This is a little bit different from the systems of equation setup, but it's simpler, but we need to understand the setup, number 1, and number 2, what we're going to do with this information. So first, everybody look up, pens down. Check this out. Let me explain something over here on the side. I'm going to take a side step. We know that if I take this, check this out, 10 over 20. And it says here that it's peanuts are half of the mixture. What is half in percentage?
50%.
50%. How can I write that as a fraction?
1 over 2 or 5 over 100.
Half, 1 over 2, or 50 over 100. Is that correct? Watch. I'm going to write it like this. Pay attention, please. 50 over 100 or 10 over 20 is the same as 5 over 10, which is, check this out. Is that correct?
Yes.
All right. But notice that I started by writing these equal to the percent as a fraction. This was a percent, but then I took off the percent and I wrote it as a fraction. Are we there? Now that we have that, so pay attention. We want to do a new mix. So if here, to write it as a percent, I wrote 10 over 20 equals 50%. My new mix will be what? 10 plus P over, and what is that equal to? Equal to what? 70. But instead of 70%, what do I write?
Over 100.
Over 100. Does everybody see that? Can I simplify this a little anymore? Yes. So I'm going to go like this, and I'm left with 10 plus P over 20 plus P equals 7 over 10. Copy that, and you know what to do from there. Is that correct? Cross multiply because we have a proportion and solve. So copy that, and then we'll finish it off together. Okay, here we go. Therefore, cross multiply. Let's see, 7 times 20 plus P. What is 7 times 20? 140 plus 7P equals 10 times 10 plus P. That's 100 plus 10P. Do we know what to do from there? Yeah. What's my smallest variable? 7 minus 7P minus 7P. We're left with 140 equals 100 plus 3P. What do I do from there? Minus 100 minus 100. We're left with 40 equals 3P. Then at the end, we divide by 3. Divide by 3. 13 and 1/3 ounces of peanuts in the mixture. So what would be our statement? Omar should add 13 and 1/3 ounce of peanuts to make the mixture 70% peanuts. 10Q. So just look at the setup. That's probably the only thing that you need to worry about, because everything else we already know what to do, right? And notice this one, we don't have to substitute the P into anything else like the systems of equations. This one, it's a straightforward answer. Okay? Yes.
So I forget how you don't put the 10%.
Here? Oh, because that's a given. And when we write our equation, we know that the mixture, has to equal the percent. Yeah. Right. Okay. Let's do another one. You do this next one by yourself. Here we go. Example 3. It says, Omar has 30 ounces of a snack mix that is half peanuts, half raisins. How many ounces of peanuts should he have to make a mix of 60%? So, on this one, you don't have to copy the whole thing. Start from the information given, set up your table, and solve. Go. You got 2 minutes. No. Go. Okay, here we go. Okay, let's see. Your table should look something like this.
Hey, Mr. Q.
Thank you. It's improving as we continue, yes. So, by looking at this, let's see, our original was 30 ounces, therefore half of it is peanuts, so that's 15. Our new mix should have 15 plus P and 30 plus P, is that correct?
Yes.
Then from there, we write our equation, 15 plus P over 30 plus P equals 60%. And 60% as a fraction is 60 over 100. But if you get rid of some zeros, it's 6/10. And can't we simplify that a little bit more? 15 plus p over 30 plus p equals 3/5. Cross multiply. This becomes 90 plus 3p equals 75 plus 5p. From there, get all variables to one side, minus 3p minus 3p. We're left with 90 equals 75 plus 2p. From there, subtract 75. We're left with 15 equals 2p, divide by 2, divide by 2. Therefore, this is 7 1/2 ounces of peanuts. And in your statement, right? Yeah. Then you write it as a fraction, change it into a decimal. Yeah. All right. So make sure you write, yes. The 60% as a fraction is 60 over 100.
60 over 100.
Okay. Yeah. All right. So let's move on. So we're done with the first type of mixture problem. Now let's go to the next one. Here we go. Copy this next one down, please. Okay, copy this, please. Example 6. Example 6 says, Amber runs a 16-mile trail while Dave walks. Amber runs 4 miles faster than Dave. It takes Dave 2 hours longer than Amber to cover the 16 miles. How long does it take Amber to complete the trip? Copy that, please.
Wait, I'm better than Amber.
All right. So, by looking at this, it looks like they're talking about miles per hour and so on and so forth. What does that remind you of?
That one table that we did a lot like.
A table with a rate problem, is that correct? So therefore we draw 3 lines down. 1, 2, 3. 2 across. Yeah, since this one involves rate, that's where we do the three column one. But this one, instead of doing distance times time, times DRT, distance times rate, not bad. Rate times time equals distance. We're going to start with the distance this time. So right here, distance, time, rate. We're going to write this first column for the first person that they talked about, which was Amber. And then from there, Dave. Okay? So far, so good? Yeah, Twisty Q. All right. So it says, Amber runs along a 16-mile trail. So what is the distance? 16. And then, how much time does it take her? Let's see, what's the question? How long does it take Amber? Do we know how long?
No, X.
So we label this X.
W.
And the rate, everybody look up, the rate, it looks like here we're writing as miles per hour. So we're going to write miles over hours, miles per hour. So, using this information, what were the miles? 16. And do we know how many hours? No, over X. Second, Dave. How long, what was the distance for Dave? 16. And then it says Dave walks takes 2 hours longer than Amber. X plus 2. So our rate would be what? 16 over X plus 2. So far so good?
Yeah.
So now check this out. I'm going to take this information and do this. Watch. I have 16 over x plus 2 equals 16 over x. Are we there?
Yeah.
Okay. However, does that make sense? Let's double check our information. This is Dave's rate. This is Amber's rate, and it's saying that they are equal.
No.
No, what's wrong here?
Dave has longer. Dave is
Who took longer?
Dave.
Dave. So that means in time, who went faster? Amber. By how much?
By 2 hours.
No, we're talking about here in regards to, we already got the time in here, right? We already got the time compensated for. 4 miles. 4 miles an hour. So if she was faster 4 miles an hour, do I put plus or do I put minus? Minus 4. This is the only thing that's going to be different from all the other setups. We set up our proportion. Here it is. And then it's minus 4. Give me a second. We're almost done. So at this point, do we know how to solve these?
Yes.
Yes, we need to multiply times the LCD. What would be our LCD?
X plus 2.
LCD is x times x plus 2. We multiply everything across. This becomes 16 times x plus 2 over x plus 2 equals 16 times x plus 2 over x minus 4 times x plus 2. You see the giant ones?
Yes.
Let me get some room here. Okay. A giant one here is right here. We're left with 16x equals. Giant one right here are the x's, and I'm going to distribute the 16. That's 16x plus 32. And this, let's see, negative 4 times x, that's negative 4x. So I'm going to distribute negative 4 in here. That becomes what? 4x squared minus 8x. Can we combine stuff?
Yes.
Yeah, so let's see. We are left with 16x equals, I'm going to write this in standard form. I'm going to start with negative 4x squared. We got 16 minus 8x, that is what?
8x.
Plus 8x plus 32. Are we done?
No.
No. This is starting to look familiar. We need to get this 16x to this side. Subtract 16x. Subtract 16x. We're left with 0 equals negative 4x squared minus 8x plus 32. Does this look familiar?
Yes.
Yes, and to solve this, we start with what? GCF. Little bit 0 equals negative 4 times x squared plus 2x minus 8. And you know what to do from there. Okay? Homework for tonight is found on page what?
31.
Numbers
3, 4, 6, and 7.
3, 4, 6, and 7. Yeah, turning your homework on your way out, everyone. See you guys tomorrow. Enjoy your homework. No, just the homework from last night.